Hello. I'm tired. A little loopy, and I've just been drinking a little bit too because I spent the last 4 days just looking at a black box, trying to figure out why I'm not rendering a damn sprite to the screen. And this is for Windows, just for context. But I do have the Phrost engine technically running now. Here it is in all of its glory. Um, I'm not going to wait till it gets to 100,000 because it does take quite a bit of time. The computer I'm running on is quite slow. It is an AMD FX 8350. It's slightly overclocked, but not by much. So all core boost, I think, is like 4.2 at most. Um, yeah, and it's while it seems quite high, is actually really terrible. This thing is like 8 times slower than my M1 Mac Mini. So, as I have said all of that, and I look at the actual GPU performance, it's like 3%. And it's trying to render 50,000 right now. Once it gets to 100,000, it's going to be like 6 or 7 frames a second. So it's really slow. But there's no point for me to try to get it to there. It's just showing you. I just wanted to show you like how little GPU it's actually using. If it could actually reach any higher, it would be a little bit higher. So let me show you what a completely native C++ version would look like here. If I go, come on, where's my taskbar? Is this going to show? Here we go. So if I move this and I go to release, yeah. So this is the completely native C++ version. If I can show this properly. And this is going to max out around 30 frames a second or 40 frames a second, sorry. And that's just the maximum throughput. I am screen recording, so it's probably going to drop down to like 38 frames a second. But yeah, even then, I still have plenty of headroom. I had benchmarked this previously, and coincidentally, the 9070 is very close to the M1 processor's GPU performance. It's just the CPU I have is not there. So you can see I'm getting 38 frames a second. When I did this on my M1 Mac Mini, I was getting double the frame rate, and it wasn't even like CPU bound. I think it was like almost 80 frames a second for like a native C++ version, and this is a native C++ version with DirectX 11. I don't even want to attempt DirectX 12 right now or Vulkan yet. I'll save that for my Linux and Android builds, but I just wanted to get something to work, and I do have it to work. The whole I also tried a couple things because I spent so much time trying to figure all this stuff out. I'm not sure if I already mentioned this, but on Saturday I spent out protocol buffers, didn't work out. I spent today, since I got it to start to work, looking at multi-threading because I wanted to bring multi-threading to the PHP version of this or PHP aspect of it too. You can have like multiple runtimes going, so you can kind of distribute some of your workload across these, since it's always going to be CPU bound. There's probably never going to be an instance where your game is going to be GPU bound if you're thinking of like it's a 2D game. It's just not possible unless you did something really crazy with the shader compilation section. Um, so yeah, I was working with the C++ version. I don't. Let me see here if I have that project right now. Let's just bring it to this window. And yeah, so I was working with multi-threading, and I first had the issue. Okay, I need to share my loop logic with my render logic. I need to have the sprite map kind of shared between these, but not in a way that's going to be impeding. I've done this previously in C, and my biggest issue is that thread locking just takes so much time. It can be very easily overwhelmed when you have your update loop running at 60 frames a second, and then your render loop is trying to just trying to get like a little foot in, a little step in to try to get a little nibble of that data that it needs to lock just for a couple of seconds or milliseconds so it can render it to a screen, and it just can't do it because your update logic is running too fast. And I remember doing this with Raylib where I try to like march down, like bring down the frame rate of your logic so that it'll give more opportunity for the render engine to work with it. And this is exactly what happened here. Everything that I've done previously with Raylib is what was happening here. And I tried to do a couple of smarter things. One was so I just do straight locking and stuff like that. I actually implemented a way to, wait, is this a multi-threading? No, it's a single-threaded version. I try to do a way to just copy the data. And I have to, and if you think about like a double buffer for graphics rendering, it's kind of like that concept, but I can't exactly do a full swap because then I'll lose all the data I just put into it. The whole point of a double buffer is you just kind of get something like a blank slate to start with. And that's not really what I want. I want to be able to copy it. And as I was doing it, I was like, okay, well, if I'm not copying, if I'm not manipulating 100,000 sprites, I'm only doing like 10. I don't need to copy all 100,000 sprites every single frame. So I have things to where I check the size of all the sprites I've changed. And if it's more than 80% of all the sprites in the sprite map, then I just do a full copy over. And then I swap it with the write and read buffers, well, not buffers, but like the write maps for sprites and the read maps for sprites as well. Because I'm always writing to a bit of data that's completely separate than what the render engine is going to pick from. I just need to lock it just enough to be able to do the swap in write logic, then I can just let it go. This way I'm not locking it for the entire duration of my logic loop. So if that takes, 60 milliseconds, I'm not actually locking it for the full 60 milliseconds. I'm only locking it for the 2 milliseconds it takes to copy over the 100,000 sprites and then to swap that over with the write. Another thing I try to do with all this is that render to a buffer, present that buffer, and then when I actually can get here, um, if my lock took too long, I'll just fall back to the previous frame. So my render engine can keep running without getting stuck on waiting for a lock to happen. Because what would happen when you're getting at like these lower frame rates is that it would get locked for so long that it'll never get another lock. And so there would never be a subsequent update. And so what I was trying to do was write to a buffer and then blitz to the copy of that buffer. So then if I was to fail to lock, I can still re-render the previous frame. That's not really that ideal, but effectively I'm clearing out the whole thing anyway. So when I was rendering it, it kept going blank. Like you'd see all these blips and blanks of rendered frames because it couldn't get the lock on the sprite map, the read sprite map, and it just had to skip over it. So rather than it skip over it and render nothing, I would basically render the previous frame. Um, I think try for try lock 4 is completely broken for time mechanics because it doesn't work at all. It never gives up. If that makes any sense. Maybe that's something to do with the Microsoft Visual Studio C++ compiler, but yeah, it doesn't seem to work at all. So all this effort I was putting to it didn't matter. And even then, when I did all of that work, it tanked my performance all the way down. Like the 7 frames that I was mentioning for my PHP logic was how fast this engine was running in multi-thread. And so the takeaway that I got from all this, while I spent quite a bit of time working on the multi-threaded version, hoping to be able to take any of this and pull it back into the Phrost engine to get this separation of the rendering with the logic. I'm sure there will be some benefit, but that benefit will only ever exist if I was making a 3D engine, because then you'll be pounding the GPU much harder. You'll have much longer cycles in your CPU transferring over that data, where right now that's just not the case. It's barely even being touched in terms of graphical issues that you would be hitting against. And so yeah, it was a complete waste of time, but at least it was a waste of time that I repeated yet for a second time because, like I said, I tried this with Raylib, and I tried to do some extra steps to make it a little bit smarter and resilient against some of the issues I was running against. And yeah, it just didn't pan out. So yeah, this was giving me, I think, like 12 frames a second, or else the single threaded version is the 40 frames a second. So running in a single thread anyways was far better performance because I'm not waiting for locks, obviously, and I'm not having to copy over 100,000 sprites every single frame to be able to offload it to my GPU renderer. Other than that, not much else to say. Not much else progress. Um, my next journey now is to get this to run on Android, and I might stop there. I don't know yet. The thing is that while all this is nice to get like a baseline for all the code bits that I need to run on these different operating systems, I'm really getting kind of burnt out on getting stuck. I'm scared for my next adventure into the Android realm, getting this to work on an Android phone, that I'm just gonna spend another 4 days smashing my head into something to yield zero results. Like I'm usually okay with like just spending hours and hours getting nowhere, like what I just did now was multi-threading. But when I am looking at the same code for days and it's literally doing absolutely nothing different than before, it's frustrating. And the thing that I ran into that was the issue was the dumbest thing here. And the thing I was like going to bed, I was going grocery shopping, thinking about how to solve this. I got to the point where I was doing a DirectX version specifically, and when I was doing the DirectX version, it it dawned on me what I was doing wrong with BGFX, which was I was setting the native display rather than the native window handler. And that was it. It was simply just swapping these two fields from a null pointer to whatever this is here, swapping them around. That was it. It fixed it. Well, mostly fixed it. There were some issues with the scaling of the quads and how I'm loading up textures a little bit. But beyond that, that was it. That was all I needed. And after that, it was like, oh, it was a big weight being lifted because I finally got something to freaking render after 4 days. And I was already fighting with the compiler to get PHP to compile with the embedded version and stuff like that. Um, so I don't know. I'm just getting a little burnt out. I'd rather be working on the engine itself than getting to all these other platforms. But I know it's going to be incredibly important to hit all these different marks because that was my big thing with Raylet PHP was that I couldn't get there. It was impossible to be rendering for iOS. It's really difficult to get this to move onto Android in the way that it's set up to run. And to have this custom runtime that I can port virtually anywhere is nice. And I want to be able to prove that for my initial release. It's just how much more gas I have in me to get there is still the question.